Hello everyone, hope you all are doing well. So today we are going to discuss the next topic of our geography series, and the topic we are going to discuss today is earthquake. Okay, so in the last video we did a overview of all the geomorphic process, and preceding to it we will start earthquakes today, and in the next videos we will do volcanoes and then further on. Okay, so let's start. And before starting I must let you know one thing, that please do make notes. Okay, and if you make notes it will be very helpful to you in revisions. Okay, so please do make notes and keep revising those notes. It will be very helpful to you. So now let's start. So earthquake, so what is earthquake? So earthquakes are tremors or shivers felt on the surface of earth. We all know it. Tremors or shivers felt on surface of earth. So there are various definitions of earthquake. I will not go in deep of that. We all know what earthquake is. So generally this happens when rocks break interior of earth. When happens when rocks break in interior of earth, and due to this breaking in interior portions of the earth, a energy is produced, and that energy is realized or released in form of seismic waves. And energy is released in form of seismic waves, and these seismic waves led to the happening of earthquake. Now suppose this is our earth, and suppose here there are the energy is releasing from here. Okay, so this is the portion, this portion is known as focus or hypocenter. Focus slash hypocenter. So this is the point where energy is released. Point where energy is released. And parallel to this focus is the epicenter. So this is on the surface. Okay, epicenter. Epicenter. So epicenter is the first place where seismic waves reach earth. Okay, you often see in news that a earthquake took place and the epicenter was in Nepal. So that is the Nepal is the place where the seismic waves reach the earth first. Okay, so that is the epicenter. It is the first place where seismic waves reach the earth. And it is always perpendicular to focus or shortest distance to focus. Always perpendicular to focus or shortest distance to focus. So suppose this is the focus, so it will be always perpendicular to the focus, or kind of the shortest distance to the focus where it will reach. So this is what about hypocenter and epicenter. Do not get confused. A hypocenter is a point from where energy is released. It is inside the earth. But epicenter is the point where it hits the earth for the first time. Okay. So these are the basic things you need to know about earthquake. Now there are various types of earthquake. Types, or you can say there are various things which lead to the causes of earthquake. Types plus causes. So the first one is the plate tectonic induced earthquake. Plate tectonic induced earthquake, that is due to the movement of plates. And for example, you can observe this in Pacific ring of fire. and this is the place specific ring of fire where maximum number of earthquakes on earth take place. More than 60% of earthquakes of our earth take place near the specific ring of fire. Okay. Secondly, we have fault induced earthquake. Fault induced earthquake due to the movement of faults. For example, you can mention here that Bhuj earthquake was due to Allah Bund fault. Due to Allah Bund fault. Secondly, we have Turkey earthquake. This was due to Anatolian fault. Next, we have reservoir induced earthquake. Reservoir induced earthquake. For example, a earthquake was due to the movement or movement and tensions in reservoir in Koyna Dam. Okay. Due to the breakage of Koyna Dam, there was an earthquake. So this can be termed as reservoir induced earthquake. We have also volcanic eruption induced earthquake. Volcanic eruption induced earthquake, and this generally happens due to the presence of acidic magma. In the volcano, we will discuss in detail about acidic and basic magma, but just remember that acidic magma is explosive type of eruption. Explosive type of eruption, and due to this explosion, earthquake takes place. And this erosion, the acidic magma, or you can say, can be highly seen in Pacific Ring of Fire. Okay. The Pacific Ring of Fire is high in volcanoes and high in earthquakes. Do remember it. Now there is a fifth also, that is due to anthropogenic causes. Anthropogenic causes, that is due to man-made causes. For example, such as deep mining, underground explosions, ground explosions. So these are in termed as anthropogenic causes due to man-made activities. So these are the 4 5 type or 4 5 causes of earthquakes. So I hope you understand this. You can simply write down it, and do remember the examples. Okay, sometimes they can generally ask you that the recent earthquakes in Turkey was due to which of the following. They will give due to plate tectonics, due to fault, due to reservoir induced, due to volcanic eruption. So you should know it. A basic understanding should be there. Now let's move to the next part of the topic, that is type of seismic waves. Okay, types of seismic waves. So there are various types of seismic waves generated during the earthquake. So generally the major ones are the two types, that is body waves and the surface waves. So let's start with body waves first. So body waves is again classified into two types, that is P waves and S waves. So these P waves are known as primary waves and S waves are known as secondary waves. Okay, by differentiation we will understand both of them. So P waves are first to be born. P waves, S waves. First to be born, whereas S waves is the second to be born. They get born after P waves. Second to be born. Secondly, P waves are the fastest waves. They travel at the speed of 10 km per second. 10 km per second, whereas S waves travel at the speed of 5 to 6 km per second. P waves are analogous to sound waves. Analogous to sound waves. Do remember this differentiation because these are very important. Have been asked several times. and S waves are analogous to light waves. P waves can travel into both solid, liquid, and gases. P waves can travel into solid, they can travel into liquid, and they can even travel into gases. Whereas S waves can only travel into solid. Okay, only solid. Important point, to remember it. Okay. Secondly, in P waves, the direction of propagation and vibration is parallel to one another. Here, direction of propagation and vibration is I'm mentioning here parallel to one another. Whereas in S waves, this direction of propagation to vibration is perpendicular to one another. Okay, so this is a very important major point, that in P waves these are parallel, whereas in S waves these are perpendicular. So do remember it. Okay, very important point. So this is the differentiation between P waves and S waves, and these are the types of body waves. Now let's move to the surface waves. Surface waves, the second types of seismic waves. So surface waves is again classified into two types. Uh, Before, just know a brief about surface waves and body waves, which I have not mentioned here. So body waves generally travel along interiors of Earth. They travel along interiors of Earth. That is under the surface of Earth where energy is released. But as waves produced, not as waves, surface waves are produced when body waves interact with surface rocks, interact with surface rocks and other surface materials present in the surface, these are formed. So generally remember, when body waves hit the surface, surface waves are formed. And surface waves are again of two types, that is Rayleigh and love waves. Rayleigh and love. So Rayleigh waves are again here the direction of propagation and vibration is direction of propagation and vibration is perpendicular, whereas in love waves it is again perpendicular. But the love waves are the most destructive waves, one of the most destructive waves. See what happens? P waves, sorry, Rayleigh waves, not P waves. Rayleigh waves moves like this. I am explaining here. Suppose this is the surface, so Rayleigh waves will move like this, up down. But these love waves move like this. Okay, not only up and down, but they will move east to west also, taking some amount of surface also. Okay, okay, that is, they will first go back and then come front like a snake. So they cause the most destruction. Okay, so these are the most destructive waves. So this was about both body waves and surface waves and their types: P waves, S waves, Rayleigh waves, love waves, all have been explained. So please do remember this. Types of seismic waves are one of the most important topics and high chances that they can be asked in examinations. And recently Myanmar earthquake was also there. So you should remember it, that I am mentioning here. For Myanmar earthquake, India had Operation Brahma. Operation Brahma, where it supported with relief supplies to Myanmar. So these are about the waves. Now, how can we measure these waves? So measurement of earthquake. Measurement of earthquakes. So generally there are two important scales. First one is the Richter scale or even Richter scale. Richter scale, it is from 1 to 10 scale. Okay, 1 means the magnitude is low and 10 means the magnitude is very high. So it measures the magnitude, that is amount of energy released at focus. amount of energy released at focus. It is open-ended logarithmic scale. Open-ended logarithmic scale. It is scientific and objective measurement of earthquake. Scientific and objective management of earthquake. Then again, we have the second most important known scale is Mercalli scale or modified Mercalli scale. Modified Mercalli scale. So here, instead of magnitude, we measure the intensity. That is damage done by earthquake. Damage done by earthquake. Its scale is from 1 to 12. And it generally measures subjective measurement. It is not scientific measurements but subjective measurement. Subjective measurement, not scientific. Whereas in richer scale, you will see that it is scientific measurement. One another scale is there, although it is not that popular, but you should know as Rosie-Farrell scale. So it also measures intensity only, not magnitude, but intensity like Mercalli scale, and its scale is from 1 to 11, as I remember. So these are the generally remember Richter scale and Mercalli scale. There are high chances of being asked if asked. Seldom they will touch Rosie-Farrell scale because that is not that much popular scale. So these are the measurement. These are the scales through which earthquake can be measured. Generally, we use Richter scale, which is known as. Now, let's move to the next topic of the earthquake only, that is shadow zone of seismic waves. Shadow zone of seismic waves. So it is the area on surface that fails to record a particular seismic waves on seismograph. It is area on surface that fails to record a particular seismic waves on seismograph. Particular seismic waves on seismograph. It occurs due to varying density in interior of Earth. It occurs due to varying density in interior of Earth that results in refraction and bending of seismic waves. That results in refraction and bending of seismic waves. Okay. So first of all, we will see the shadow zone of P waves. So let me take another wave page. Shadow zone of P waves. Suppose this is our Earth. Okay. And we all know that the outer core is made of liquid. Okay. Outer core is liquid in nature. So what happens? Suppose here we have the hypocenter. The energy is released. So energy starts releasing to all the directions. So what happens here when it will be like this here? Energy is released in all directions. But when P, this is of P waves. First we are dealing with P waves. But when these waves reach to the outer core, due to varying density as it is liquid, the instead of refraction completely this side, they bend and they move like this. Okay. So there is a refraction here. So what you find that this zone from here to here and from here to here, the seismograph is not able to receive P waves. So this is known as the shadow zone of P waves. It is from 105 degree to 145 degree around. Sometimes they will also mention that 102 to 142 degree, that is also correct. Okay, it is not that exact 145 degree it is, but depending on the hypocenter that deflects. Okay, so on an average it will be around 105 to 145 degree. Let it be A, let it be B. So A and B are the shadow zones of P waves. Now let's see the shadow zone of S waves. So suppose this is the hypocenter. From here the energy is releasing, and this is again outer core. So what you will see there, that the S waves are not able to come out through the outer core. This will be like this, this will bend like this. Why? Because we all know that S waves doesn't move in the liquid, and the outer part is liquid, melting, molten stage. Okay, so that is why they are not able to, they are not able to be observed in the seismograph from this to this region. Okay, due to the presence of liquid outer core, and we all know that S waves cannot travel into liquid medium. So this is from 105 degree approx to 105 degree approx. Okay, so this will be the shadow zone of S waves. So these were the most important topics that had to be explained in earthquake, and I hope you understand all of this. We have tried to keep it simple and also give you the best knowledge of all the important concepts. So this was all for earthquake. I hope you understand all the important things and you have made notes also. So if you like it, please press the like button, please do share, and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis. So if you like, if you share, if you subscribe, it motivates us to make more such videos for you. So that is all for today. Have a nice day. Thank you.